Okay, so for this lesson, we are going to be working with trigonometric identities, how to work with them, how to simplify trig expressions using them, and then also how to prove some trig equations. Okay, so first, these are all the trig identities you'll be expected to know. The first that we've gone over many of times, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. And since tangent is equal to sine over cosine, then cotangent is equal to cosine over sine. Okay, so those are the ones we've worked with before. The other three identities, which are based off the Pythagorean theorem, are that sine squared x plus cosine squared x equals 1. When you see trig functions where the squared is in the middle, that just means that's the same as, so sine of 2x is just equal to sine of x squared. Okay, that's just what that means. Right, so sine squared x plus cosine squared x equals 1. Tan squared x plus 1 equals secant squared x. 1 plus cotangent squared x equals cosecant squared x. The even and odd identities, which I think we've talked about before too, sine of a negative x is just equal to negative sine of x, and cosine of a negative x is just equal to cosine of x. And tan of negative x equals negative tan of x. Okay, and these cofunction identities we won't use that much today, but they're just saying that these sine, cosine, tangents are just related to each other by a simple shift to the left or right by pi over 2. And you might have even noticed that while graphing some of your sine and cosine functions, you know, if you shift sine of x to the right by pi over 2, it looks very similar to negative cosine x, stuff like that. So that's what these identities are, is that you can kind of get your other trig functions by a simple transformation to the left or right of another trig function. But like I said, we won't be using these too much. But these are all very important, and I would highly recommend putting these on your formula sheet for your next quiz and exam. Okay. All right, so the first thing we're going to do is simplify trig expression. So we have this expression here, cosine t plus tan of t times sine of t, and we're asked to simplify it. And when we simplify it, we usually you're going to get something where it's just one trig function, or maybe just 1 over a trig function and stuff like that. So you'll see. So the first thing I like to do when simplifying is just start simplifying stuff I know. So cosine of t, I can't really simplify that, so I'm going to let that be. But I know tan of t is equal to sine of t over cosine of t. Then the sine of t can't be simplified. Notice that that gives me cosine of t plus sine squared of t over cosine of t. If I want to add these two expressions together, I have to make this a fraction with the same denominator as cosine t. So that means I'm going to multiply it by a special 1. And that special 1, let me make some room to write my special 1. That special 1 is going to be cosine t over cosine of t. So that becomes cosine squared t, since cosine of t times cosine of t is cosine squared t, plus sine squared t, and both are over cosine of t. Since they both have the same denominator now, I can add a cross, and I get cosine squared t plus sine squared t is all over cosine t. This is an identity, right? This is the identity that cosine squared t plus sine squared t is equal to 1. So if this whole thing is equal to 1, then I can just substitute in 1 and get 1 over cosine of t, right? So I just substitute this guy into here, right? Substitute this guy into here. Okay, and I know that 1 over cosine is simply secant with t, right? 1 over cosine is secant. So then this is my simplified answer. Okay, so notice how I use things that I know. I knew I could write tan of t as sine over cosine, and then from there I added terms. I had to add a special, multiply by a special 1 here to get like denominators, and then once I did that, I got cosine squared over sine plus sine squared, and I know that cosine squared plus sine squared equals 1. And if you didn't pick up on these trig functions right away, that's okay. You probably have to refer to this guy, especially when you started out. But for someone like me who has been using these identities a long time, it's easier for me to pick them up. So if you don't see them that fast, you know, that's okay. Take your time, ask questions if you are feeling stuck. Okay, but the more practice, the easier you'll find it to be. Okay, so now we have sine theta over cosine theta plus cosine theta over 1 plus sine theta. So we want to, we definitely want to combine these two terms together. And to do that, we are going to have them have like denominators. Right now, this one has a denominator of cosine, and this one has a denominator of 1 plus sine theta. So we're going to have to multiply both of them by a special 1. For the first term, I'm going to multiply it by 1 plus sine theta over 1 plus sine theta. My term is sine theta over cosine theta. You might have been tempted to say, oh, well, this is equal to tan of theta, which is true. But usually when we're simplifying, we don't want to compress stuff. We want to kind of expand stuff and then see if things cancel out. So before you start substituting in more simplified expressions, start by expanding it out and seeing if you can combine stuff and hopefully eliminate stuff. Okay, and then this is added to cosine of theta over 1 plus sine theta. I'm going to multiply this by a special 1 of cosine theta over cosine theta. And notice that now when I do this, I multiply these two together and these two together, and that's going to give me a like denominator of cosine theta times 1 plus sine theta. The numerator for this guy is sine sine theta times 1 plus sine theta over cosine theta times 1 plus sine theta plus cosine squared theta plus just cosine squared theta all over cosine theta times 1 plus sine theta. Now they have the same denominator, so I can add the numerators together. I'm going to go ahead and distribute out the sine. That's going to give me sine of theta plus sine squared of theta plus cosine squared of theta all over cosine of theta times 1 plus sine of theta. Okay. Notice that here we have that sine squared theta plus cosine squared theta. Even though we have a different variable, we have theta instead of x or t, the identity still holds. So this whole thing can be translated to 1. So I'm going to draw that here. This whole thing equals 1. So then I'm going to get, continue this up here, sine theta plus 1 all over cosine theta times sine theta plus 1. Notice I have a sine theta plus 1 in the numerator and in the denominator, so I can cancel them out. And I'm left with, again, 1 over cosine theta, which is equal to secant theta. Okay, so this is my simplified expression. So to combine two fractions, I always have to make sure they have like denominators, and I'm usually going to have to multiply them by special ones to get there. Okay. All right, next thing we're going to do is proving trig identities. So with proving trig identities, you're usually going to have some equation, some left-hand side equals some right-hand side. And what we mean by prove an identity is, does the left-hand side in fact equal the right-hand side? So to do that, there'll be some steps, and we're going to use a lot of the same techniques that we learned when simplifying. We're going to apply it to these. So we start. So we're going to start by picking one of the sides, and you usually want to pick the more complicated side. So in this case, it's definitely this guy. There's definitely a lot more going on than just simply sine squared of x. So we pick one side, we use that size, we use our identities, and then simplify that side. And then we hope to eventually get this equal to this, which would then prove that this identity is true. I think you'll understand more what I mean once we do an example. But we always pick the more complicated side, simplify it, and then check to see if it did actually equal the right-hand side. Okay, so here's that same expression on the last slide. So I'm going to pick the more complicated one. So cosine of x secant of x minus cosine of x. I'm going to simplify it. So the first thing I'm going to do is, I know that secant of x is 1 over cosine. So cosine of x is 1 times 1 over cosine of x minus cosine of x. I want to possibly combine these two terms together, so I again have to have them have like denominators. So I'm going to multiply this side by a special 1 of cosine of x over cosine of x. That gives me cosine of x times 1 over cosine of x minus cosine squared of x over cosine of x. Now I can combine them since they have the same denominator, and that gives me cosine of x times 1 minus cosine of squared x over cosine of x. Notice that I have a cosine here, and it's being multiplied by something over cosine of x, so I can cancel out the cosines. This leaves me with 1 minus cosine squared of x. Now, this doesn't look like a trig identity that we've seen before, but sometimes we have to manipulate trig identities to get what we want. So a trig identity I know that has cosine squared of x is sine squared of x plus cosine squared x equals 1. Notice if I subtract cosine squared x on both sides, I get sine squared x equals 1 minus cosine squared x. And that's what I have here, right? I have 1 minus cosine squared x here and 1 minus cosine squared x here. This identity tells me that 1 minus cosine squared x equals sine squared x. So then I say this whole thing is equal to sine squared x, and that's what I wanted. So my identity is proven. Okay, so once I get to my right-hand side, then I'm done. That is, in fact, proving a trig identity. Okay, let's do another example. So here we have 2 tan theta secant of theta equals 1 over 1 minus sine theta minus 1 over 1 plus sine theta. So just like before, my first step is to pick the more complicated side. And in this case, it's gonna be this side. Okay, so I'm going to simplify the right-hand side. So 1 over 1 minus sine theta minus 1 over plus sine theta. So to combine these two expressions, I'm going to have like denominators, and to do that, I'm going to multiply it by a special one. You'll see special ones are coming up a lot here. They are very useful when combining fractions. So for this first one, I'm going to multiply it by 1 plus sine theta over 1 plus sine theta. And then this one I'm going to multiply by 1 minus sine theta over 1 minus sine theta. That gives me 1 plus sine theta over 1 plus sine theta times 1 minus sine theta minus 1 minus sine theta over 1 plus sine theta times 1 minus sine theta. It's a long one. Okay, now they have the same denominator, so I can combine the top. That gets me 1 plus sine theta minus, now this minus sign is applied to this entire numerator, so I have to distribute it out. So minus 1 and then minus sine theta, which becomes plus sine theta. I'm also going to factor out this denominator. So I'm going to do, I'm sorry, not factor out, expand out. So I'm going to do 1 times 1, which is 1, times 1 minus, times 1 plus 1 minus sine theta. So that's going to be negative sine theta. And then these two multiplied together, that's plus sine theta. And then these two, which are which will give us minus sine squared theta. Okay, I'm going to add a page so I can keep going. So this is where I left off with. Notice that these two, minus sine theta and plus sine theta, cancel out, and here the one and the negative one cancel out. So on the top, we're left with sine theta plus sine theta, which is 2 sine theta. And on the bottom, we're left with 1 minus sine squared theta. Okay, so again, we're going to have to use that trick of kind of messing around with a trig identity we know. So we know that sine squared theta plus cosine squared theta equals 1. If I subtract sine squared theta from both sides, I'm left with cosine squared theta is equal to 1 minus sine squared theta. That's what I have over here. So this thing equals this thing. So I can simply just substitute in cosine squared theta. Yeah, I can substitute in cosine squared theta. 2 sine theta over cosine squared theta. We're not quite there yet, but I can kind of expand out the bottom. So this is really 2 times sine theta over cosine theta times 1 over cosine theta, right? If I multiply across, I'm left with 2 sine theta cosine squared theta. I know that sine theta over cosine theta is tangent, and I know 1 over cosine theta is secant. So this whole thing becomes 2 tan theta times secant theta. Okay, and that proves my identity since that is the left-hand side. Okay, that one was a bit tricky, seeing this part, I think, but I just kind of broke up cosine squared theta into cosine theta times cosine theta. Okay. Okay, so for this one, here we have another trig identity. We have cosine of u over 1 minus sine of u equals secant of u plus tan of u. Both of these seem pretty complicated, but I'm going to choose the left-hand side to simplify. So just because I think it's easier to get something to look like this rather than to get something to look like this. So here we have cosine of u over 1 minus sine of u. A trick that you might see come up a lot is for us to be able to use the sine squared u plus cosine squared u equals 1 identity, if we see a 1 minus sine of u or a 1 minus cosine of u or something similar to that, we multiply by a special one, which is 1 plus sine of u, which is kind of like what we did in the last one. And notice when we did that, we get cosine of u times 1 plus sine of u on the numerator, and then on the denominator, we get 1 minus sine of u, 1 plus sine of u. This is the exact same factors that we got before, and notice that when we expanded it out, we were left with cosine of u, 1 plus sine of u. We were left with 1 minus sine squared of u, which given that same identity, we get cosine of u times 1 plus sine of u all over cosine squared u. Right, this is the exact same substitution we did previously, right here. Okay. So now we have cosine squared of u. Now we can simplify that. So we have a cosine of u here, and we have a cosine square u here. So that means that my cosine gets canceled out here, and my squared gets canceled out here. I'm left with 1 plus sine of u over cosine of u. I can distribute out my cosine of u, kind of expand my fractions, which gives me 1 over cosine of u plus sine of u over cosine of u. 1 over cosine of u is equal to secant of u. And sine of u over cosine u is tangent of u, which is our right-hand side. So that means our trig identity has been proven. Okay, and then one more example. Here we have the left-hand and right-hand side are both complicated. So instead of picking one and then seeing if it equals the other, we're going to simplify both and see if we get the same simplification for both sides. So let's start with the left-hand side. Here we have 1 plus cosine of t over cosine of t. I'm going to split up my into two fractions, so I get 1 over cosine of t plus cosine of t over cosine of t. Cosine of t over cosine of t is just 1, right? This is just 1, and this is secant of t, which we've seen 100 times now. Secant of t plus 1, so that's the left-hand side. And the right-hand side, we hope we get the same simplification. Here we have tan squared t over secant t minus 1. If we remember from our identity here, tan squared x plus 1 equals secant squared x. So we have, I'll write it up here, tan squared t plus 1 equals secant squared t. If I subtract 1, I get tan squared of t equals secant squared t minus 1. Like that, right? So I'm going to substitute that in for tan squared t. That gives me, let me highlight it, this is equal to this, right? So that gives me secant squared t minus 1 over secant t minus 1. Okay. This is a difference of squares, so we can factor it out and write it as secant t plus 1 and secant t minus 1 over secant t minus 1. Notice we have a secant t in the minus 1 in the numerator and 1 in the denominator, so they cancel out, and we're left with secant t plus 1, which is exactly what we got on the left-hand side. Okay, so that then proves our trig identity. I know there's a lot of steps with these, and like I said at the beginning, it just takes a lot of practice. So take your time, ask questions. If you get stuck, please let me know. It's sometimes you go down one path of simplifying it and you realize you want to try a different method. That happens many a times. Just try to be patient, and give yourself time to really work through them. As always, if you have any questions, please do ask. And with that, you can move on to the lesson 16 homework, and we will do more practice problems like this on our next class.